continuing with graph number 2, sorry, I did a little mistake here. If I look on the left side, you'll see that I begin at -1 and end at +1. Now this should look a little familiar because this looks very similar to a function that you may have already discussed, a sinusoidal function. Now these look like wavelengths and they usually they bounce between -1 and 1. If you took pre-calc, this sounds very, very familiar. So I would say that I have -1, comma, +1. Now, if you recall, a line is made up of several dots that are so compact that they make an appearance of a solid line. So because I have a solid line, that's same as solid dot, I would say it's inclusive. You could also write that in inequality notation. That would look like -1 less than x, less than or equal to 1. Either of those two ways, don't have to write both. Now, bottoms up, starting at the bottom, I have a negative arrow and a positive arrow. So, that would look like -infinity, +infinity. You could even say -infinity less than y less than infinity, or you could say all real numbers, or you could literally write that out as well. Okay, best way to know that you have all real numbers, you have 2 arrows and they're pointed in opposite directions. Number 23 is very simple. You may want to refer to page 23. It says graph a linear relationship with a y-intercept at 0, +4, which you'll find on the y-axis here, and a slope of -3. Now recall that slope is the change in y over the change in x. That means that you move up if it's positive or down if it's negative. And if you have a negative symbol, you should keep it on the numerator in order to keep your denominator positive. So then you always move to the right. So according to my slope of -3, which I can turn into a fraction by putting it over 1, I would go down 3 units from my y-intercept. 1, 2, 3. And always go to the right 1 unit. And then I would repeat. And I could go backwards up 3 to the left 1. And of course, connect with a line. Number 24. Find a slope and y-intercept of the graph line to write the equation in slope-intercept form. That seems really easy, although for those of you with, not so good vision, you might not realize that my y-intercept is not a whole number. So what I want to do is use these 2 coordinates that are clearly defined at -5, 5 and -3, 0. Now visually I can see that this line is negative, and that if I move from left to right, it appears that I go down 1, 2, 3, 4, 5 units, and I move to the right 2. That was the easy part. Now I need to find my y-intercept, which is almost exactly the same question that we had on number 14. So we're going to go ahead and do it the exact same way and solve. So I have my slope, and now I just need to substitute in an x and a y value. I can use either of these 2 coordinates as my x and y values, but to be quite honest, I'm feeling lazy, so I'm going to go with the smaller numbers here, and let's substitute in. Just like so. Yeah, I made a boo-boo, sorry. And remember, to multiply fractions, turn this into a fraction, multiply straight across. So I have 0 equals, negative times a negative is a positive 15 over 2 times 1 is 2. And now I just need to get my b alone by subtracting my 15 halves. So therefore b is equal to negative 15 over 2. Leave it as a fraction, but do write it as a coordinate. So therefore y is equal to my m slope, x plus my b, my y-intercept. And that's my answer. So let's move on to number 25. I'm going to move through this one a little bit quicker since this is pretty much the same question as we had on number 22, which is also on page 22 of your interactive notebook. So domain is from left to right, but we're not done. Let's continue. All right, so let's begin at the x value of negative 5, which is inclusive. And then we're going to follow all the way over to 1, which is also inclusive. Now we have a break here. So according to page 22, we connect that break using a union. And then we continue with 2, which is exclusive. And we finally end at an inclusive 5. Now bottoms up, starting at the bottom. And as I continue, so I do have an opening here, although I do have a solid line straight across. So I have the y value 1 is exclusive here, but also included here. So it kind of fills in the hole. So let's keep going. All right. And there we go, right up at the top. Perfect. So we begin at negative 2, y value is inclusive. All the way up to the top, I have a solid line at 4, which is also inclusive. Page 25 you can use for number 26, and I'll continue that on my last video for this.